Now coming to the next topic, the effects of force. When you play football, the football is kept in the center of the field. Whenever you kick it, it moves towards a given direction and the ball sets into motion. Here we can move the ball from its position of rest by applying a force on it, or we can stop the moving ball and bring it back to the rest by catching it. As as one can change the direction of an object by applying the suitable force on it. For example, in the cricket, the speed of a ball hit by a batsman reduces to zero when the fielder catches it. You might have seen children playing with a rubber tire by pushing it with a stick. They push the tire again and again with stick to increase its speed. With every push, they are applying a little more force on the moving tire in the direction of motion. Hence, the speed of a tire increases continuously. If the net force acts in the direction of motion, the speed of object moving with constant speed also increases. If the net force acts in the direction opposite to the motion, then it either slows down the object or brings it to rest, or it may change the direction of motion. As one more example, when we hit the striker in the carom board, not only the coin changes the direction, but the striker changes its direction too. So, on the whole, thus a force can change the state of a motion of an object. From these examples, we can say that net force stops a moving object or moves a stationary object and also changes the speed as well as direction of a moving object. So let us discuss some other effects of force. Consider a thin balloon and blow air into it. The shape changes. Then tie its open end with a thread. Now press the air-filled balloon again and here also the shape changes due to the net effect of force. So observe the other examples like stretching rubber band, squeezing a sponge, tearing a paper, crushing plastic bottle, making a chapati or breaking a glass. When the action of force applied on a stretching rubber band, we can see the change in its shape is permanent. When action of force applied on a squeezing sponge, it is also a temporary change in its shape. Tearing a paper, whereas in this, it is a permanent change. Crushing a plastic bottle, the change in the uh, shape is permanent. Making a chapati, here also the change in the shape is temporary. Breaking a glass, the change in the shape is permanent. Whatever the examples we have discussed, we can understand that force not only changes the state of motion of an object but also changes the shape of an object. It may change the shape temporarily or permanently based on the nature of the object and the force applied on it. Now one more effect of force with area of contact. When you take a pencil, just push its rounded end on your palm. Now you push the other end of the pencil gently so that the sharp end is on your palm. For example, you might have noticed the effect of force depends on the area of contact on which the force is acting. When there is a decrease in area of contact of force, the effect of force increases. I've seen the porters place turbans or talpaga on their heads when they have to carry heavy loads. Why do school bags and shopping bags have broad straps as handles? Have you wondered why lorries carrying heavy loads have a larger number of broader tires? In these all examples, when there is a decrease in area of contact of the force or load, then the effect of force increases and vice versa. Now I am going to define pressure. The force acting perpendicularly on a unit area of surface is called a pressure. Pressure is equal to force per area. The SI unit of pressure is Newton per meter square. Next, why does the sharper side of a knife cuts more easily than the blunt side of it? A sharp side of a knife has a smaller area of contact. Therefore, for the small amount of force applied on it, the sharp side of a knife exerts more pressure than the blunt side and hence cuts easily. In this above example, if the surface area is smaller, the pressure will be greater. If you use a larger area, you are spreading on the force and the pressure becomes smaller.